this sum. Now look at this sum. Each term is the height times the width. So each term gives the area of a rectangle. So the sum corresponds to the area of all the rectangles and so approximates the area of the quarter circle. So this whole expression for the volume of a quarter cylinder is h times the area of a quarter circle. And that's h multiplied by pi r squared over 4, or pi r squared h. So the volume of a whole cylinder V is pi r squared h.
We'll use the same method of approximation to find the volume of this pyramid. It's got height h, and its base is a square whose side has length b. What we have to do first is to decide how to approximate the volume. And I'll approximate it like this. This time, each block has square cross-section. We need an expression for the volume of this block. If it's xi from the vertex, and we call the height yi, then the square has side twice that. And so its area is 4yi squared. So the volume is area 4yi squared times thickness, delta xi. And I've written that down here. So to get the volume of the pyramid, we sum over all blocks from 0 to h and take the limit as delta xi tends to 0. Now to make progress, I need to rewrite this yi squared in terms of xi's. Well, here we can see the angle theta, which is half the angle at the top of the pyramid. And tan theta is just yi divided by xi. In other words, yi equals xi tan theta. Making this substitution gives this. And we can write this expression as this integral. Now, we can evaluate that integral, and as before, 4 tan squared theta is just a constant, and x squared has primitive 1/3 x cubed. Evaluating this from x equals 0 to x equals h gives this expression as the volume of the pyramid. Now this formula is probably not the one that you're familiar with. We need to express it in terms of the height h of the pyramid and its base b. But here we can see that tan theta equals b over 2 divided by h, or 2h tan theta equals b. Making this substitution, we can rewrite this last expression as 1/3 b squared h. And you may recognize that as 1/3 base area times height.
Now let's look at this similar volume. It's a cone. Out of this, we'll find a general method which will work for nearly all the volumes you'll ever need to find. So we're going to find the volume of this cone, which is circular base of radius r and height h. I'll approximate it this way, using discs. This disc is xi from the vertex, and its radius is yi. So if we write down its volume, it's the area times the thickness. That's pi yi squared times delta x I. So summing over all discs from 0 to h, we have this. Now, taking the limit as delta xi tends to 0 gives an integral which we can write as the integral from 0 to h of pi y squared dx. If you look at this integral for the volume, the surprising thing is that we haven't used the fact that we're dealing with a cone. Now that will come in when we write this y squared in terms of something involving x. All that we've used so far is the fact that the cone has circular cross-section. Now one way of getting volumes with circular cross-section